We are on 7.1 homework in the textbook. We are starting with question number 1. So it says, how is the expression with this exponent read? So we read that 4 to the power of 10. And of course, you could say 4 to the 10th power, something along those lines. All good. Number 2, just kind of going over some vocabulary here. So looking at 10x to the 9th, we want to make sure we can identify everything here. And so for letter A, the base is whatever's being raised to a power. So the base here is the x. The 10 is not being raised to a power. This is not 10 to the 9th. It's just x to the 9th. And that is being multiplied by 10. So the base is just x. Okay, the power here, when we talk about a power, that is actually x to the 9th. Okay, when a number is written like that with an exponent, that is called a power. Letter C, the exponent itself is 9. And letter D, the coefficient, even when we don't have exponents, coefficients are always the number that's being multiplied to a variable, so it's 10. Okay, number 3. We're going to calculate 7 to the 3rd without a calculator. 7 times 7 times 7. Now, I'm not too concerned with you doing this in your head. We just need to make sure that we understand 7 to the 3rd is 7 times 7 times 7, which comes out to 343. That's the reason it says without a calculator, is it's not testing your mental math skills. It's making sure you understand it's not 7 times 3, it's 7 times 7 times 7. And of course, when you calculate this in your calculator, you're going to get the same thing of 343. And your keys for this, if you're actually going to do it with the exponent and not do 7 times 7 times 7, you're going to hit the 7 key. You're going to hit the raise 2 key, which is right here. And then you're going to put in the exponent that you want, which for us was 3. And so we're going to get 343. But again, right underneath of it, you could show 7 times 7 times 7, also 343. Okay, giving us the same thing. Those are equivalent. Okay, number 4. Rewriting this using exponents. So starting with this one, a little confusing just on how it's written. These dots just mean there's a continuation here. Okay, so there's a bunch of 5/9s being multiplied. We don't know how many. We don't know if it's 10 times, 20 times, 5 times. It just says t times, so we're going to have to write an expression. T represents the number of times. So if this was 10 times itself, it would be raised to the 10th power. So it's raised to the t power. Now when you put a fraction and you raise it, you want to put that fraction in parentheses like this, raised to the power, because if you don't, then it's going to look like the exponent is only on the numerator, the 5, which is different than this whole thing being raised to the t. Okay, so we got to make sure we put those parentheses there. Okay, number 5. The only thing being repeated is the -3. So I'm going to start with that. This is -3 raised to the 4th power. There's 4 of them. Notice how I put it in parentheses. That's important. The negative is repeated, which means it needs to be included with the exponent. So there's got to be parentheses. 18 is just being multiplied by this. And so that's going to just sit out in front. Number 6, it's 21 times x to a power. So 21 times x. And then you'd have to count them all up. And there's 10 of them. And so it's just to the 10th power. All right, going down to number 8, now going specific to the investments we were talking about here and interest. Okay, the money you deposit, so letter A, is your principal, which is right here with the 3 I's. Letter B, the interest paid. Okay, the interest paid. And then if you jump down for a second, the yearly percentage paid. Okay, so we got to be able to tell the difference between those two. So the interest paid is the compound interest itself. Letter C, the yearly percentage paid as a percentage, that's the annual yield. You can see it's yearly and annual mean the same thing. Yearly and annual mean the same thing. So the actual interest that's paid is called compound interest. And then the actual percentage, like 3% paid back, 3% annual yields. Okay, that is your yearly percentage paid. So number 9, we're going to write an expression for the amount in the bank after 1 year. So 1 year. So going back to our formula here, right off to the side, the amount is the principal times 1 plus the rate raised to the time. So when we go ahead and set this up, we want to know what's the amount that's in this. So P is going to be represented by the dollars, which we don't have here. So we're just going to put P. It's going to get multiplied by 1 plus the rate. Now 2% is 0.02. Raised to the time, which in this case is 1. They said 1 year. Okay. So I'm going to go ahead and just simplify everything in here. This becomes 1.02, and you can go straight to that. That's fine. And raised to the first, we don't even have to write. And so this is a good answer right there. And number 10, similarly, it's just going to be P times 1.0. Okay, if it's a single-digit percent, 3%, 2%, 5%, even if there's numbers after it, there's always got to be 1.0. If you started with a 3, that's 30-something percent. So we need the 0, 3, that's 3%, and then the 2, 5 to finish it off. And we don't need anything else because, again, this was being raised to the first. Okay, you can write it like this. You could also write it as 1.02p, like that. Perfectly fine. 1.0325p. Okay, either one of those are fine. Okay, number 11. Write the compound interest formula. So again, A equals principal times 1 plus the rate raised to the time. That's letter A. Letter B. What does the A represent? It's the amount, total amount. Letter C, what does the P stand for? That's your principal, which is the initial amount of money that you've got there, what you start with. Letter D, what is R? I like to just call R the rate, the percentage, but they refer to that as the annual yield. We need to know that those are the same. And then letter E, what does T represent? That's time, but in most cases, that's going to represent years. Specifically in this compound interest formula, it's going to be years. Okay, but it's time in general. Okay, going over to the next page. Number 12, let's start putting some numbers in this formula now. So you're depositing 300, that's your principal. So my amount is going to equal 300 times my annual yield of 2.5%. So it's 1 plus my rate. That's 0.02. That's 2%. And the 5. You got to have that. If you just did 0.25, that's 25%. That's a huge gain. Okay, you don't get that in a savings account, 25%. Okay, 2.5%, 0.025. And it's going to ask you for 5 years. If you wanted to just go ahead and write this as 1.025, that's fine. That's going to be raised to the 5th. You can plug this all in your calculator at once here. So 300 times, and if you want the parentheses, that's fine, but you don't actually need them. 1.025 raised to the 5th power. And now we are talking about money, so we are going to round that off. So $339.42. So 13. The bank is offering 4.81% on a 5-year CD, which is a certificate of deposit. That means you put the money in, and in 5 years you get it back with the interest. So again, principal is what you start with. You're putting $2,000 in. After 5 years, you're going to get more than that back. 1.0481. And this is, again, 5 years. So if I plug all that in, 2,000 times 1.0481 raised to the 5th. How much is it going to be worth? $2,529.55. So if you're willing to give up the $2,000 for 5 years, they will give you basically an extra $529 after that time. Okay, 14, we got to be careful here. They are going to ask the question differently. They're not going to say how much money do you have or what's it worth. They're saying how much interest will be earned. So neither one of these answers told us the interest, because we had our principal, it earned interest, and then we have our final total amount. So if we want the interest, we'd have to go back and take out the principal. The interest is how much it increased by. So here would have been the $39.42 because you started with $300. Here you'd have to take the $2,000 out. So you earned $529.55 interest. So we're going to go ahead and run the formula here, but we got to go back and make sure we answer the actual question. Not how much money do we have, but how much interest will be earned. So my principal was $1,000. 1.05125 is my rate, and it's being raised to 7 for 7 years. So let's go ahead and just plug this right in. 1,000 times 1.05125 raised to the 7th. Okay, so I'm going to get this. Now you can't round that up. They're not going to give you extra money. Okay, you actually have to round that down. They're not going to just round up and give you money that you haven't earned. So it's 86 cents. Now this is the amount that you're going to have in your account. So the interest is how much it increased, because you gave them the original $1,000. The interest is the extra now that you're going to earn on top of that. And so your interest, you got to take the 1,000 out of that. And so it's $418.86. That's what you've earned. That's the interest. Okay, 15. We're comparing two different people. So we have Susanna, who put $250 in at a rate of 4%, 1.04. We'll talk about the years. It says they leave them for 2 years, so let's go ahead and put the 2 right there. And we have Jake, who also puts $250 in at 8% over 2 years. So if we go ahead and run these numbers, for letter A, we're going to find out the interest. So again, not the total amount, but the interest. So 250 times 1.04 raised to the second is $270.40. That's the total amount. The interest is how much it went up. So it went up $20.40. That's Susanna. Jake now, 250 times 1.08 raised to the second, 291.6. So he went up $41.60. So that's all letter A. Letter B now says his interest rate is twice Susanna's, right? He's 8%, she's 4%. Does he earn twice the interest that Susanna does? And so if you double $20.40, you don't get this, right? So the answer here is no. And the reason is, after that first year, Jake has earned more interest, and he now gets 8% on that bigger amount. So every single year he's getting 8% on whatever is left in that account. So after year 1, it is going to be exactly double. He earned 8%, she earned 4%. It's going to be exactly double. But then you've got your next year right after that, okay? And he's going to be earning 8% on a bigger amount than her. And so it's not equal. So that's why it's not exactly double. All right, we are going to skip to 17. We're going to be making some charts. I'm going to go to a new page here. So this is all the information we're going to use here for 17. Donica invested $100 in an account. She gets 10%. On the same day, Todd deposited $200 in an account. He only earns 5%. Below are the graph in the spreadsheet that compare how much they make. So you can see Todd starts with more, but he's only making 5%. So eventually, Donica, who started with less, earning 10%, is going to pass him in the amount of money that she has. You can see it on the chart and the graph. So 17A, what's the formula to show what she started with? So she started with $100, and her rate is 10%, which is 1.10 or 1.1 raised to, now the time is going to vary. It's going to be all over the place. So I'm going to put T for time right there. Letter B, complete the column indicating the amounts in her account. So I'm just going to do the rest of them. I'm not going to write every single one that's already there. So I'm going to start with 14, 16, 18, and 20. And so if I want to run these numbers, all I got to do is plug the time, or the number of years, into this equation. So T is going to become 14, and then 16, and then 18, and then 20. So it's 100 times 1.1 raised to the 14th. And so that's $379.74. Again, you can't round it up. The bank is not going to round up for you and give you extra money. Next one, 16, 100 times 1.1 raised to the 16th. So $459.49. 100 times 1.1 raised to the 18th. $555.99. And last but not least, raised to the 20th. $672.74. Okay, question 18. We're going to do the same exact thing for Todd's account. So part A, it's 200. That's what he started with. 1.05, he's getting 5% raised to the T. And again, we're going to just fill in his chart: 14, 16, 18, 20. So 200 times 1.05 raised to the 14th. $395.98. 200 times 1.05 raised to the 16th. $436.57. Raised to the 18th. $481.32. And $530.65. Okay, 19. In what year are they going to have the same amount? So you can see right here, there's less at 14, year 14, and then year 16, all of a sudden, Donica has more. What was the other guy's name? Todd. So this is Todd, Danica or Donica. Okay, she started with 100 and she's got less. Even year 14, right? She's got less. But by year 16, she's got more. So I'm going to say somewhere around year 15. Okay, we don't have the exact number based on the information here, but we know somewhere in between 14 and 16, they would be equal, so somewhere around year 15. All right, after question 19, we jump down to 24, so some review here. 24, we're just going to go ahead and solve this. Keep our equation solving skills nice and fresh. So when I see this, first thing I'm going to do is distribute. That's 6c minus 18 plus 4. Go ahead and simplify this whole side. Putting that together, that's negative 14. Bring this down. I've got c's on both sides. I'm getting rid of the smaller one. So that's going to leave me 32c minus 14 equals negative 14. I'm going to add 14 here. And that's going to cancel, so I have to fill that space. That's 0. And then we're starting to fall into the bad habit of going, oh, it's no solution, but that's not true. I'm dividing by 32. I can divide 0 by 32, and the answer is 0. Okay, it is not a no solution. All right, we're going all the way through 27, so we've got 25. So a couple things. I need to start simplifying both sides. I'm going to do it at the same time. I'm going to distribute. That's 16. 1/8 times 8. 1/8 of 1. If you split it into 8 pieces and take 1, that's just 1. And so this is just a 1u. And on this side, I'm going to put my u's together. It's a 2 minus a 1, so it's a 1u plus 1. I've got u on both sides, so I'm going to go ahead and subtract. And they go away, and I'm left with 16 is greater than 1. That is true. It is all real numbers. 26. Which formula best describes the numbers in the table at the right? And so what we need to do is just test this out. So I'm just grabbing a random one. If I plugged in 0 for x, 2 times 0 should be 0, and I got 1. So that's eliminated. If I put 0 raised to the second, I'm not going to get 1, so that's not true. If I take 2 and I raise it to the 0, I actually do get 1. I haven't really talked too much about that, but I do get 1. 2 raised to the second is 4. 2 raised to the fourth. Well, let's see. 2 raised to the fourth is 16. 2 raised to the sixth is 64. 2 raised to the eighth is 256. So for number 26, I have found the answer is letter C. I never tried this one out, but if I did, I would get different answers than all of these. Now, some of them may work. Like if you plugged in 0, 0 plus 1 is 1. 0 plus that 1 is 1, and so it works. But 2 plus 1, that's 2. I'm sorry, 2 plus 1 is 3, plus the 2 is 5, not 4. So you can see that doesn't work either. So letter C is the only one that works there. And so 27. Find t if 2 to the t is 32. So we can kind of work down the line here. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And 2 to the eighth is 32. And so the answer here is, why did I say 2 to the eighth? I'm going too fast, right? 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth is 32. And the answer there is 5. Because we are solving for t, for 2 to the t equals 32. Okay, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth would be the correct answer.